So I'll make you once recall all those things of the array manipulation. So till now we have seen that we can do reshape and all those things, right? We saw till the shape manipulation, and I think the transpose also we saw, right? So we saw the how the reshape work, how the flat works, flatten works, level transpose, T roll access, and all those things, right? Similarly, there are some terms now for when we want to join kind of arrays. Okay, so let's say you have an array X. Let it be np dot array okay. So let this be an array of 1 second. Okay, so this is an array. Let it be a 2-dimension array, 1 2 3 and 4 5 6. Similarly, let's take a y another array. This be 4 5 6 and 1 2 and 3. Okay, so this is my x and y now. Oh, I haven't already. Okay, so this is my x array and y array. If I just print it on the x and y, you can see this is my x and so does the y. Okay, now see, if I want to add this up, the x and the y, if I want to add on these, or I not add on, you then join these. Okay, you want to join these in kind of rows and columns in the right. So for that, what you will do, you will have some specific type for writing on the joining, right? So we'll be joining on some axis, right? So axis could be 1 or 0, as I said yesterday, day before yesterday, right? So 0 and the 1. So 0 will stand for your row and some 5 for the columns, right? So A. And let's see. So for joining, you have methods like concatenations, concatenate. Okay, so there is a term called as concatenate. How we do in the strings, similarly. So this concatenate, what happens in this one? This joins a sequence of arrays along an axis defined. Okay, that could be a 0 or 1. Okay, this concatenate with join a sequence of arrays along the axis defined, whether you define 0 or 1. Okay. So we'll see both of them. Okay, so what you have to do is just np dot concatenate. If I just write on print and just say np dot concatenate, and now concatenate. Now this will take one single parameter. Either you give, so whatever you want to concatenate, you will have to give a single parameter. You can't write it like concatenate the x and y, because these will be the two parameters, right? So you need only one. So you combine this into one tuple, that is this one. Okay, now this is one single parameter. As you can see, this is now one single parameter in the concatenate. So you are concatenating x and y now. Let's see what comes there. So we saw that this has been concatenated as 1, 2, 3, 4, 5, 6, the x axis, the x array, and then the 4, 5, 6, and the 1, 2, 3 as the y array. So it has not been added up, okay? It has been joined in one particular thing. And the default value or default view we can see is a column 1, right? So these has been joined according to the columns, not as the kind of rows. Okay. So by default, your things are always joined in a column. So what do you understand by that? Okay, if I write this particular statement, if I just write this particular statement, and I give my axis, and here I give my axis to be 1. So what I am getting is a row concatenation. That is, every particular thing has been joined in a row. It is 1, 2, 3, and 4, 5, 6. The 4, 5, 6, and 1, 2, 3 as respective to this one. 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. So 1 stands for your row. Understood? It is your 1 stands for one stands for row. Similarly, this is nothing but the excess of 0. This is the excess of 0. So 0 stands for the columns. Alright. So when you run the excess of 0, again you will be getting the same value. Because by default it is a column wise. Right? By default this is a column wise one. And this is your row 1. So many a times what happens, students get it confused, like what are these concatenations happening there, right? So there are more functions for that. For joining the arrays, we have a function called as stack. Okay, there is a function called as stack. So there are several methods in the stack to discuss. Today we'll sum up this number. So this stack is nothing but this joins a sequence of array using or along a new axis. Okay, so what you say that this joins sequence of arrays along x-axis. Okay, guys, from tomorrow for till we study about the data structures and all those things. So from tomorrow your timing would be 3:45 to 5:45. Okay, combined batch that AIML students will also learn in that batch. So your timing would be 3:45 to 5:45. We're learning the data structures there. So this joins a sequence of arrays along the x-axis. Okay, let's focus on this now. Not a x-axis, along axis I say. Along axis. And that can be a new axis. So what does new axis means? Right. So if I write np, okay. If I write print np dot the stack of x and y. So what you are getting is the two of them in the separate axis. Okay, a new axis has been defined to them. It is one axis and this is one axis. Okay. Now, for getting these things in a row, for getting this joining as similar as in the row 1, right? In the sixth cell, what we have done, this particular output, if we want this particular output, we have some function which can replace that x is equals to 1, and that function is called as hstack. Now hstack particularly name will suggest you that this is a horizontal stacking. Okay, that is hstack. So this joins the arrays, or better than join, let's write this stack the arrays. In horizontal way, or horizontal axis, right? Okay. So what there is done, that is just only the print np dot its stack, and that's it. You don't need to define any of these kind of arrays over there, shape, right? So you just have to write x and y, and that's all. So this is your array. All right, 1 2 3 4 5 6, and that, like, right? If you only write np dot its stack, so this is your similar array, as you can see, right? Exactly the same as you have got in the let me zoom out. You can just make it there. So you can see this is exactly the same as we did it here, right? So this one and this one similar. Similarly, you have vstack, right? So like the same, you have their vstack. Now vstack will give you vertical stacking, so that will be given in the column wise. So by default, every time anything you will get is by default by the 0. Okay. So vstack will give you x and y as your row wise or column wise. Okay, this is the just a method you can say on what you get it here, right? So there are also splits, and a lot of there are in the splitting area. So there are the uh, function for, we have seen the joining function, right? Similarly, there are functions which are used for splitting the arrays. Okay, so for splitting the arrays, you have some different functions there. That is called as your split functions, right? So now we'll try to learn about them. We have seen them shape concatenation, joining function we have seen, and now let's learn about the split functions or split arrays. Okay, so this is your splitting arrays now. Okay, now how to split down the arrays? So for that you have function there. Right? Yeah. So first of all, there is a function called as split. Okay, that is split. If you write it here, so this is only split, and what it does, this will split an array into multiple sub arrays. Okay, that is, if I say that this will split an array into multiple sub arrays. Okay, so just let's write something and split it this one, right? So let's say I'm writing x, which is np dot arrange, and let's say this be an 8.0, np dot arrange of 8.0. Now let me print this as x. Okay, now we are printing the array, that is the split array. So we are splitting this x, and we want that this to be splitted in let's take 9.0 first. So we want this to be splitted into 3 parts. Okay, So when we run this, we will see an array that is a 3 array. Okay, we'll be seeing 3 different arrays, a 1, 2, and 3. Now these will be having some different values. Now these will be having all the different parts, 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? So this is how split works on. Similarly, you have another module. So let's just hope that if in this case, if it in this case, if I run this and I take it to be in the 10 parts, so what happens? This says that array split does not result in equal division. Okay, that is, if we use this function to split 9 parameters into 10 parts. Okay, we have 9 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 9 numbers and we are splitting into 10 kind of arrays, 10 sub arrays. So that is not possible in this. So for that there is another function called as array split. So this will split whatever you write. So this will split the arrays, and how is split? So you are splitting the x into 10 parts, right? So 9, so for the 9 times it could be splitted out, right? It could be just taken in and it would be like having till 9, okay? So till 8 you will be getting every individual array. So what about the next one, the 10th one, right? For the 9th one, what will for the 10th one, what it will happen? It will create a blank array. Okay, so if you write, if you just separate or split an array more than the number of elements it is having, okay, so you can, if you don't know actually, let's say if you don't know what you do, let's say you are writing x equals 1000 and you are splitting this as a kind of x plus x, or let's say 1. So what will happen? This will give you an individual array, you can see, right? So what I have done is I have taken some 1000, 10,000 numbers and I have splitted them with the length of x plus 1, right? So what happened here, this array of 0, 1, 2, 3 has been, individual array has been formed, and you can see an individual array of at least 10,000, right? So you can manage out to see some individual arrays of till the 9999, right, according to my range. So I have got to see these all things there, right? So I have written x by, and the length I have written the length of the x plus 1. So I have got that. So, okay, so let's just detect these things. Let's make it up to 100. That's enough. So a length of x plus 1 dot. So you can get it till here. Okay, so it is splitting this array into with how many parts? The length of the array. The length of the array is, if you see the length of the array, what is the length of the array? This is none but the 100. Okay, that is 100. So length of 100 you are getting there. So that depends whatever you write. Let's say you want to split it into 100 parts. You are not writing anything there. You just run it. So this will be your number of arrays. Okay, and now if you say that you want a data type also, you are taking your arrange. Let's say you are taking your arrange, and if you declare your D type to be a float, sorry, to be an integer 64. So you'll be getting everything of the integer. Understood, right? So this is how split arrays work, or array split works, right? Similarly, we have the kind of H split also. H split is an horizontal splitting one. Okay, so let's say that you have some, let's say, 2-dimension array. Okay, let's take x to be equals to np dot a, and let's say where we arrange 16 numbers. Okay, and then reshape this. to 4. Okay, that's good. So let's print out this. So we'll be getting a 0, 3 to the 15 out there. Okay, now to split this in the horizontal way. So horizontal way splitting is kind of what you write. Let's say I'm writing np dot h split. Okay, and then I'm saying this to be x to be splitted in the two parts. Okay, I want this x to split down in two of the parts. So what will happen if I split this in two of the partitions? This will be splitted out as a horizontal splitting. It is from 0 to 13 you are getting, and from 0 to 15. But if you write your horizontal, it will give you, one second, one second, hold on. There is 31st, right? So, 1, 2, 3. Yes. So it's split. See what happens when you use edge split. This is doing horizontal splitting. What you see is there you are getting a column wise separation, right? This is a column wise separation. That is, this has been taken as one column from 0 to 13, and these two columns, and then these two columns, right? If you write here 3, so that would be an error. So you need to define as the perfect shape what you are having, right? Similarly, so you need to understand that when you write H split, you are getting in the column wise, and when you write your V split, you will get into the horizontal, so the row wise. Okay. So when you write this, you will be getting row wise, and for this you will be getting column wise. So that is probably a reverse of the names. Okay. So V split will give you a splitting in the rows, and the H will give you the columns. That is the kind of a split what we do is here. Okay. Similarly, there is something called as resize. Okay, resize. So what is resize? When you use np dot resize, let me tell you. This will resize like we do the reshape, right? Okay, so that there we force the array to make a shape of that much, right? Here we force the array to make a size of whatever we want. So we are saying I want a resize of the objects, and for that let me first write array. So let's say this is an array, and let this be as 0 and 1, and let these be as 2 oblique 3. Okay, this is an array, and I'm saying, okay, you can see, let me zoom it there. So this is an array now, and I'm saying I want to resize this in the 8 parts. Okay, in the 8 parts, or let's say I want this to be in 8 parts, resizing this in 8 parts. So what will happen if I write x comma 8? X comma the 8 parts. So what will happen? What happens here? Some missing argument saying Resize the structure, new shape. Okay, one is extra there. So what you see is this is an array of some 1 2 2 3 0 1 2 3. So what has been here? You have four individual elements. Okay, this resize. What does resize this? You are increasing the number of the size of the array, right? So what does the size tell, guys? Size tells the total number of elements present in the array. So you are resizing it to 8. So you have total number of elements as 4, and you want to resize it to 8. So there you are having this 4 repeated again. That is 0 1 2 3 repeated as 4 0 1 2 3, right? So you are getting there, right? So you have got resize. Let's say this is to be resize or res. So np dot res is there, and when you print your resize, that is or when you print your res, and you will be getting this 0 1 2 3 0 1 2 3. Similarly, if I resize this, if I resize this and I say I want to resize x in the terms of let's say 2 by 4, okay, 2 by 4. So what will happen? This will be resized in 2 of the rows and the 4 individual elements in every 2 rows. Similarly, that depends what you write. If I say 3 by 9, so we'll be getting 3 rows and 9 columns. The resization, that is resize, what resize gives you actually the number of elements we are having, that is 9 3. This is the shape I want, and this is the number of sizes, right? So what will happen? 0 1 2 3 0 1 2 3 0 1 2 3 0 1 2 3 will be repeating on, and you will be getting a 90 or 3. So that depends whatever you write. You want 30 by 90, you will be getting for that. So it's 30 by 90, and it is going there, right? So it's 30 by 9, so you'll be getting 30 by 9 there. So it depends on what you write. Okay, so let's make it 15. Let's make it 10. So this is your 10 by 9. So individual elements has to be dependent on. Okay. Similarly, guys, there are some things like kind of let's say now you have this array x, right? Now you want to insert or you want to append something. You want to add on something, right? So what you do there is np dot append, and you write down the things. That is kind of, let's say you want 1 2 3 and you want to add something here. Let's say you want to 5 4 5 6. So in the 1 2 3 there will be 5 4 5 6 will be added on there. Okay, understood? So that is the similar one. Let's say that you want to append so what happened? See, in the x, or let's say you want to append these things, right? So you want to append 10 20 30 in the x. So what happens? The 0 is there, and then 1 2 3, this was the part of x, and 10 20 30 has been appended there. Understood? So these are the basic functionalities what you are getting there. Okay. Similarly, there is insert method. So insert, yeah, all know how insert works on a list, right? So if you don't know, I have given there. I have made this particular one, right? So you have this. Today you are having a test of Python. This one, okay? You're having this test on the conditions, strings, list, and tuples. So you will be doing that. Okay. So if you haven't seen, I have made that kind of list over there so that you can find out. So how to work with the list. So there is a small notebook there to work on the list. So you guys can go with that. So in the list, what we do is we insert something just by giving the list name, and then we give a comma, and then we just write on the whatever we need to insert, right? Similarly, in the NumPy also, we first write the array name, and then we want to give where in which specific position you want to insert something. Right? So let's say I want to insert in the 4th position. Okay, I want to insert the fourth position, and I want to insert 10 there or 100 there, and I say that this to be xs1, that is the row wise, or there is some problems, no issues. Let's make our x again. So let's just say that x is equals to np dot array. Oh, there is one there. And let's make it two dimension. Let's say this to be a 0, 1 and 2, 3. Okay, 0, 1 and 2, 3 are there, right? And I'm resizing this and saying to be nx4 out of bounds. So see what happens. So what I said is, in this array, I want this 100 to be replaced, to be not replaced, to be inserted in the one place. That is one first. Okay, one stands right. You know what is one there? One is your second place, right? So you are inserting one. That is your second place value to be 100. So in this you can see this in the excess one you have given, that is a kind of a row. So in every thing there you are giving that in the first place it should be 100. So that is kind of thing you can just write on, and you can see how it works on. Okay. Similarly, let's say you are having an array. Let's say you are having a if we just take on this insert. Let's say you are having an array as 1, 2, 3, 4, 5, and you want to insert in the third position, and you want to insert what? You want to insert 70. So there you can see 0, 1, 2, and 3. We are having 70 there. This is how insert works on, right? So similarly, you can just work it there. The random we have worked on, right? The random we have seen. The random ones. So what we can see that I have made one res. Remember, right? We have res as this. So we have also read about the unique one, right? We have read about the unique one, what unique does. So if I want to see a unique of that, if I want to see a unique of this, and I say that this unique of res, it says that the 0, 1, 2, 3 are the unique one. Now if also I want to see the, if also I want to return the counts to be true, I'll be saying the returns of the counts. That is 0 is for 2 times, 1 is for 2 times, 2 is for 2 times, and 3 is for 2 times, right? There are 2 times for that. And also if I want to see the index, so where these has been repeated up, so I'll be getting the keyword got repeated. Oh. So return index will be also true. It is you are getting the now the index values first, and then you are getting the return of the counts. So let's say that this res is a let's say this res to be an array, and let's modify this. How we can modify? Let's say that this is a list, okay, and what we can do is, let's say for x in res x dot append okay, let's take out 50 and let's take only 20. You can get to see what I'm trying to do is let's take 20 numbers there, and So this is your rest, right? So you're having some codes over there. Alright, you're having some of the codes. Now let's say I want to see the uniqueness or this counts of all these things. So I'll run this and I can see that I can see this that these all are if I also see the length of this. So yes, something value syntax. So unique dispatcher got multiple of invalid index inverts to what is this? Let's write for this dispatcher of length of sorry, you can write it as length of this, and there you can get it. So I'm getting this as 20, and that's correct. So no individual or kind of no repetitions has been given here. So in the 20 numbers, these are the 20 codes. That is a Unicode of 8, right? And these are stored. This are given here, like in which index it is. So this code is in the second index. This code is in the but this is kind of a sorted one you're getting. So this 14396 in the second position, right? And it has been only coming for one time. This is in the fourth position and for one time. This right 1 2 3 4 5. So 1 2 3 4 5. So this is in the first position. This is 0 and this is for the one time. Let's see the first one. Yeah, so this is for the first one. Okay, this is how these are saying for you, right? So you can just count for those and you can explore these things, right? Similarly, let's take for 200 now, and let's run this. So these are your 200 codes, and let's run this. So still the length of the rest is 200, and what about the unique one if I see? So now you might be getting kind of huge data there. So np dot unique of rest. So what is the length of the uniqueness? So still we are getting it's 200 there. So there you are getting the 200. So I'm not printing rest here. Okay. So I'm not printing the unique of all those things. I'm printing only the. Okay, let's see the uniqueness that is necessary. So let's say I want to see some 2000, 20,000, and that's there. Okay, done. So now I just want to see only the 10 one, the starting 10. That's here the starting 10. That's good. Let's see only the starting 5. So there you have the starting 5. Okay, similarly you can write down for the starting 5 here. So what you say is the starting 5 of the rest has been given to you, that is these are the starting 5 values. Okay, don't go with this one. This is an unsorted way, right? Okay, because you are getting this rest as an unsorted, and this unique will give you a sorted outcome. So you are getting a particularly okay. So what you see is among these 20,000, you are getting the unique as 19,703, and the rest of are to be given. Okay, so this is saying that your particular list, whatever it is, okay, your particular, let it be any kind of whatever you have. So of that, you are getting some 5 results as this, and you are getting these things, right? Let's say we want from 10 to 20. Let's take any of the values, 10 to 20. So still there are some thing commons. Let's say up to 100 to 200, 100 to 250. Okay. So still there are some things, say. So let's say to 1500 to 3567, like that. So still you are getting okay. So there means that if you just minus on these values, it's 20,000 minus the 19,703. So you'll be getting some values, that is 297 has to be same values. Okay. So these are your unique ones, and will giving you the return counts, the return index, right? So the count you will be getting, or how many times it has been printed out. So if you don't give anything, you will be getting just the response of everything. Okay, you will be getting everything there. So to remove this kind of things, if you want to see, what you can see there is coming a dot 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 and so on, you're coming there, right? So to remove these things, if you want to see the whole, or if you want to see just the whole thing, right, not the dotted and like that, so you have to write one small line, that is import sys, and you have to set the print size, that is your print options. You have to set this to have to do this. After then, when you run this one, you will be getting the whole thing there. Now you can see everything of your data. So see guys, this is your whole OTP. Okay, this is your whole OTP, and first let's complete gives completion up to 2000, and you could manage to see somewhere. Okay, these are the index numbers. Now these are the index numbers starting from here, and meanwhile you will be getting 1122 in the last one. So here what you can see, is sometimes you will be able to see the 2 from this. Okay, sometimes you can be able to see the 2. If I write x, y and z from here, I'll make you see what is there. So what I can see is here is the 2, here is 2. You can see from this all will able to see all these things, right? So many a times we could find out 2. We can just find out the 2, and we can just see here how many times this 2 has been given there, right? So there we can see. Okay, so let's see that this is a x, y, z. Okay, I've initialized this 1, 2 and 3 as x, y and z. So now let's just print out z. So these are the z here. Now these are the counts of your z, right? So you have these much elements. Now if I just find out print the, so we apply the same thing here also. We'll just apply the unique of z, and will return the counts to be true, and will return, okay, just see the counts only. So this will say, so this is this says that particularly this z, that is your index, or that is your counts particularly. Okay, so this says that there are 1, 2, 3. Okay, that states that some numbers might be there which will be repeated, which has repeated for 3 times, right? So now some numbers might be there for 3 times. So what you do is, among of this, so unique one is 1, 2, 3. Okay, so whatever this my z is, I have the number of counts of every individual number. So there might be some numbers which might be having 2 or 3 or kind of that. Okay, so there might be some things like that. So there might be some numbers which can be of 3. So what it says that there are only one number which is having for the 3 time of occurrence. So it says that 3 is coming for the 2 times. This 1 is coming for 19,408 times. That states that 19,408 are the individual elements, and apart from this unique ones. And this because we can add all these things, right? So 2 are there. So there are 2. One particular element repeated for 2 times as 293, and this 3 for 2 times, right? So you can get a proper information of everything. So if we just pass on for the first 100 values, so you can see here. Meanwhile, you can also find out 2 here, right? So you can see the index positions, the values too. So you can also print the index positions of these things, right? So you can check on these occurrence of this first 100. So it will give you the first 100 values. So what I see is, what I can find out that this is, if it is from 1 2 3 4, okay, don't go with that. I can find out 2 here, right? I can find out the 2 here. So for that, if I want to see exactly the 2, I will have to use where. Okay, so this is a statistical uh, proper scientific computation library for you. So you can find out where this Z200, right? So where in the Z200 is coming as 2. So it will say in the area of 50, that is the 50 index value and the 85 indexed value. So there you are getting 2. Okay, yeah, here is also there. So 50 and 85. So what we'll do, we'll just print on, we'll see what is the index values. Okay. So there we'll just find out the y, I think it's y. So we'll find out the 50 value and we'll print out the value of 85. So these two are the codes, that is, of, if I write of x also. So these two are the codes which has been repeated for more than one time. So these are the two codes which has been repeated there. Understood? So like this, you can just explore the whole data. Just you can see where the values has been 2. So you will be getting, these are the areas where you're having 2 values. These are the numbers which has been repeated out. So you can just find out as like that, right? Similarly, you can just, so these are basically the counts, these are basically the index values, right? So index values are these. So if you just copy out this all, you just copy this x, if you just make it as s. So if you ever print your s, you'll be getting these things. So if I come to print, let's see now, what we can do with this data s. If I want to see the x of s, yes. So the x of s means the x of that particular index values. So this states that these are the codes which has been repeated for more than one number of time. So these are the actual codes which has been repeated for one number of time. So you guys understand how we just, I'm giving just your data, just you're giving an information, just a basic logic of how you can work with the data. So there are only 20,000 data. So there might be some situation where you can get some of the 20 like this data. So there might take some time, just wait on. Done. So it has taken how many details? You can see on it's ones, tens, 100, 1,000, 10,000, lakh, 10 lakh. So it's having 20 lakh data now. Okay. So if you see your RES, so having these much data, 20 much data. Similarly, you have assigned these values, right? Now, let's say I want to find the unique of Z. Okay. So unique of Z says that it is having now some numbers which are repeated up to 14 times also. So there are some numbers which are also repeated for the 14 times. And you're getting the particularly counts. Okay, you are getting the counts particularly and the Z values, right? So the Z is this and this is being counted. So 1 is there for at least 1, tens, 100, 1,000, 10,000 lakh. So 1 is for 1 lakh. Similarly, 2 is for there, and these are. So 14 for any number which has been repeated for 14 times, you are getting only there are 2 numbers for 14, 9 numbers for 13, 32 numbers for 12, and 142 for this, and right. Similarly, let's print out the first hundreds of all these. So we came to found that these are the first 100 values, and now you can see very less value is 1, right? So your range is very much. So your 1 would be very less percentage. If you could count the percentage of 1 in this, you could find it very less as compared to 1. Okay. So we can see this 3 as an, and we can see the y of 100. So what is my y? Y is my return of counts and z is my return of index. So I can see the return of counts, that is where it is, yeah. So I can see that z up to 100 and y up to 100, that is my indices or my index. You can say this is my index, right? So these are the indexed values, right, of these numbers which has been depicted out. So these are the z index and the counts, and has been replaced, I think so. So if you just find out where this z is becoming to be 2 s, so now you'll be getting a lot of contents, probably up to the numbers where you can see this s to be some these times, right? So this is particularly, as I'm not printing this s again out, so I'm just printing for the 51, starting 50, because I can't print everything there, because there are 2 lakh, 20 lakhs, sorry. So there are 20 lakhs. So this is the first 20 values I'm printing on till the 50 values. So why it is not taking up to there? Why it's taking the whole values again and again? Okay, no worry. So you have these kind of things, right? So this is just a sum up of what you do with what you can do with the unique one. So there are a lot of things you can do with the unique one, right? So NumPy comes to an end, going up with some of the functions more, and we'll end up this NumPy. So we have some operations, right, for finding the LCM and all those things. So we'll be doing that. So see, now let's say you want to add something, right? You want to just add on any values particularly. So how we can do that, right? So you want to add up 213, so that is 5, right? Like that. So you want to add up this x and y. We want to see some first 10 values, Unicodes. So that is for x and y. Let's say this is 1, 2, 3. So there you will get, right? Similarly, you have subtract function here, which you can work on. That's not working. Might be changed. Nobody. So you can use this mull, or mull is also not working. Alright, might be shifted there. So you can multiply. You can use multiply. That might work. That is multiply. Okay, it's flying here and there. Okay, this is working good. So subtract might also work, I think. Yes, this is working. Short form has been reduced, I think. Okay, so there you have capitalize, title, lower, upper, split, spreadness, and all those things, right? Same, very similar to the kind of things you have built now with the strings and all those methods, right? You can just find out the pi value, the sign of any right thing. You can find out the cause of any particular thing, right? For let's say the cos, and you can just find out assign the degrees, right? If you just want to see the degrees of this is a degree, and similarly you can find out these things, right? You can find out various kind of things with the mathematical outcomes, right? You can round off the things also. So I have discussed this all the things, right? So let's say like for you are using mathematical outcomes as, let's say you are using floor of minus 23.5, so you'll get minus 24.0. Remember we have that in the mathematics, right? So you can go with the same and the very same things as we have in the mathematics, like minus 23.5. So seal what gives you. So you can go with the math module what we have read. Okay, so that will give you a basic outcome of the same things has done here, but in the NumPy we have this, right? Similarly, have if you want just a reciprocal of anything, right? So let's say you want a reciprocal of anything, let's say 5. So that is 0. Why? You can write it as, let's just take it that, let's say this is 0.25. So this function will return the reciprocal of element, right? So 0.25, 1.33, there is 1, there is 0, there is 100. Alright, so this is now, let's say I want a reciprocal of this A. So these are the reciprocals of this line. Okay, that's good, right? So 0 of a reciprocal, if you find, you will be getting an infinite value. Right, similarly you get all those things. Okay, now let's say you want a power, that is if you want to see power of 2 to the power of 100. So this is, oh, what is this? You will need to assign an array first. So let's say okay. Okay, you can see the powers here, right? So this is how it works. So you just pass on the A and B and you can just find out the powers. Similarly, you can find the mod of this things np dot if you have any mod of any arrays, right? So mod functions will just give you the modulus value, right? You just write that you want the mod. So for mod, you need to define some of the arrays, like kind of you have done for A. Let's say you have written A, and that is an, okay, we have an A first. We say this is a B np dot an array, and let's say this array is 3, 5, 7. And you want to find a mod of A and B. So operands broadcast with the shapes of 2 and 3 are where shape is different. So let's say this A to B 10, 20, 30. So let's run this. So the mod of this, that is 10 divided by 3, will give you some outcome. That is nothing but the remainder. Okay. So the same thing is produced by the remainder also. If you just find out for the, so if you have a good knowledge on the, okay, the same thing will be provided. So if you have a good knowledge on the libraries, that is very much good, right? For the complex numbers, you can just find out the real number, the imaginary number, the conjugate number, and the angles of an imaginary. How? Let's say that, let's just say that this is an array, and these are some of your things, like let's say minus 5.6j, 0.23j, let's say anything. Let's take 11 point, and let's say 1 plus 11j. So this is a C and this print C. So these are the numbers 1, 2, 3 and 4. Now we can find the real part. How we can find the real part at C dot real. Not use real of, don't print this out. Just write np dot real of C. So this is the real part. Similarly, you can find out np dot imaginary of C. So these is the real part and the imaginary part. Similarly, you can find the conjugate one. So conjugate will give you Cn or J, and you can find the C. And you can also find the angles, right? The angle function. So the angle function of C. So you'll be getting every values there, right? So angle will return the complex argument. This function like for the degree parameters. So if true, the angle in degree is to return, and then otherwise giving a radians value. Okay. So this you can get in the uh, conjugate, right? So let's say you have an NumPy and array, and you want some maximum and minimum values among that. So we are having a NumPy, that is we are having this z, right? We are having z. Z is if I see z of first 10, so 19, so I can see this is an array, right? So if I want to see the maximum of an array, so I'll be just writing z dot max. So that is maximum value I'm getting, and you can also use np dot the max of z. So that will also give you the values, right? So you can find out these things using the max and the mean, and similarly for the minimum of z will give you the, oh sorry, that's capital not. So you will getting the minimum values, right? You can use, that's fine. Similarly, you can apply it for the if it is a 2D, if it is a 2D one, let's say we have it here. Let's just take this. No, not from here. Let's just say that this is our array, right? Let's just print it out. Now, if you want to find the maximum, you want to find the maximum from the x, and you are saying you want to find the from the 0 axis. So it says 12, 13, 14, 15 is the maximum value. Similarly, if you find the minimum one from the x, and you say your x is to be 1, so this will be the minimum value, that is 0, 4, 8 and 12. Okay, that is column wise. So I'm getting this one as a 1, this is a 0, 4, 5 and this. In the particular column, sorry, particular row, you are getting the particular value. Okay. So there is a function called as PTP. So this PTP function will return a range of maximum minimum number along an axis. Okay, that will return you a range of numbers. Like if you write np.ptp of x, so that will give you 15.0. What is this 15.0? That is in last one, right? So that will return you something on the axis also. If you just write x and you define that x is equals 1, so this will be the numbers and a kind of a range you are getting, right? You can also get the percentile. So percentile will give you the value you are getting in the A. Okay. So Q will be let's say that in the np dot ptp, or let's say percentile, what I was saying, that the percentage. So in the x I want to, in the, what is that? So let's say that this is your codes, right? So this is your I want to see the z. So in the z I want to see the percentage of 1. In the z I want to see the percentage of 1. So that is 1% I use there giving out. Okay. What is the percentile of 2? That is wrong, I think that is getting wrong there. why it is coming. ZR first, and what is it? 3232. Okay, let's see about the 3. Still it is 1%. What is the value of the counts of the set? On index, right? Okay. Index values. This one is engaging for 10, 5, 2, 6, 3. Hmm. 14%. Okay. 100. Z of 100. 8% values. %. Okay. So this 3 is giving for the 3% out. Comes 3. What about this 8? What about this 1? 2%. Okay. %. So the number of observations is getting out there. That's good. Okay, I'll discuss it later on. Let's see where might be some errors. Okay, I will move forward. So you can count the median of something by using this median, and you can count it for the x, or let's say for z if I want to find the median. So median is 3.0 of z. Okay, you can find the mean to right like mean, not here, mean of z, and you can find the mean out. Okay, like that you can also find the average. So average can be generated, mean can be generated, median can be generated, right? So there are mathematical functions a lot. You have seen the calculations you can do, and then you can just find out for the countings also. You can just count all things. Why that is not working? Okay, so we'll conclude this NumPy now. Okay, kind of things. Moreover, if you want to go more in the NumPy, you can just find all the things. Okay, okay. Before going to that end, let's talk about copy and use. So see, what is there a particular array? Let's say that this x is equals to 5, 7, and this y is equals to 10. Now, how to see what are the locations where these are stored, right? How to find the location? So for that, you will be using the ID of x comma y. Two arguments is take, sorry. So print out the ID of x and the ID of y. So x has been located to this address, and this is the address of y. So always you can see or check out the ID that will give you an address of that, right? You can find the address of everything from there. Any particular storage what you are writing on, you can find the address of that. Similarly, there are matrix which you can make using this function of matrix of NumPy, right? You can write for matrix, and then you can just print on the matrix if you want. So that is a matlib function. Okay, so those are not very much necessary for here. So when you want to solve the algebra function using NumPy, there you have dot product. You will get the dot product of two arrays. There you have, if you want vectors, if you have two vectors and you want a vector product, you'll be using v dot, that will be giving you a vector plottings. Okay, vector product of that. You can use the solve method to solve a linear matrix equation. You can find the multiplicative inverse of the matrix by using inv functions. Okay, so there are functions and methods to find out, and you can just plot a graph using an NumPy, right? So there are a lot of things you can do. I have this one, the desktop, I think there. Uh, so linspace empty random I full array done. Saving an array, you can save that like that, and for loading and testing files you have this one. For data types we have seen this one, right? For aggregate functions, median and standard, this can be also used, comes and for cumulative sums of the elements and all, right? For the mathematics part you can go with that. You can find out these things. I'll be sharing with this with you. For subtraction, addition, we have dealt with every of the things, right? Some might be have skipped, no worry for that, you can just go with this one. So comparison, you can just do a comparison between the arrays. You can find the correlation coefficient, standard deviation, and all those. You can sort an array using this one, right? Similarly, is to splitting an arrays, you have H split, V split, which works on stacked column wise. You have column stack, H stack, V stack, V done. delete, insert, append and resize, reshape, transpose. We did fancy indexing, so it depends. These are this method of indexing methods, right? So there we have some these done. So we have done approx everything of the NumPy, okay, which is to be needed. Apart from that, if you want any help from the NumPy itself, you can just write np.info, and then you can write the data type or the function what you want. Okay, so from tomorrow we'll be starting this pandas. Okay, we'll be dealing with the datas now. Okay, that is very important. There are some functions which are very useful for pandas. Okay, so we'll be going with one by one. Okay, and what I was saying that from, yeah, so from tomorrow till the 5 or till 4th, your timing would be uh, your timing would be 3:45 to 5:45. Okay, stop.